Okay, in this video, I'm going to talk about the predictive parser. The other name for the predictive parser is LLF1 parser. So, what is predictive parsers? Is predictive parsers are top-down parsers. It is a one type of recursive descent parser, but the difference between predictive parser and recursive descent parser is recursive descent parser uses backtracking, but predictive parser does not uses backtracking. There is no backtracking in predictive parser. So it can be implemented non-recursively by using stacked data structure. They can also be termed as LLF1 parser. The production to be applied for a non-terminal is decided based on the current input symbol. So what is LLF1? So the leftmost L denotes for scans input from left to right, and the next L denotes for leftmost derivation, and 1 denotes for look ahead input symbol. In order to overcome the limitations of recursive descent parser, so what is the limitation we have is whenever the grammar is left recursive, it will go to infinite loop. So to overcome the limitations of the recursive descent parser, so LLF1 parser is designed by using stacked data structure to explicitly hold the grammar symbols. In addition to this, left recursion is also eliminated. Common prefixes are also eliminated. So there is no left recursion as well as no left backtrack in predictive parser or LLF1 parser. So the steps for the finding the predictive parser is, first step is to compute the first, second one is to compute the follow, then we will apply the algorithm to construct the predictive parsing table. So this is a rule for computing the first. So the first of terminal is terminal itself. That is to compute the first of x, where x is a grammar symbol. If x is a terminal, suppose if x is a terminal, the first of x is the terminal itself. If x tends to epsilon is a production, then add epsilon to the first of x. Suppose if x is a non-terminal, it has a production in this form. X tends to y1, y2 up to yk is a production. Then add first of y1. So whatever the first of y1, we need to add to first of x. Suppose that y1 is a non-terminal, then we need to go to that particular non-terminal. Then we need to find the first of that non-terminal. Okay. And this is a rules for follow. So the follow of A is a set of terminals A that will appear immediately to the right of A. For the rightmost sentential form of A, dollar will be follow of A. So these are the rules. For the follow of start symbol, place the dollar. So where the dollar is the input end marker. If there is a production in this form, A tends to alpha B. A tends to alpha B beta, then everything in first of beta except epsilon is in follow of B. If you have a production in this form, A tends to alpha B beta, whatever the first of beta except epsilon, that will be the follow of B. If there is a production like this, A tends to alpha B, or a production A tends to alpha B beta, where first of beta contains epsilon, then everything in follow of A is in follow of B. This is a algorithm for constructing the parsing table. So input for construction of a predictive parsing table, what is our input is grammar G is a input, and output is parsing table. Method for each production A tends to alpha, do the following. For each terminal alpha, in first of alpha, then add A tends to alpha to M of A comma A. If epsilon is in first of alpha, then for each terminal B in follow of A, add A tends to alpha to M of A comma B. If epsilon is in first of alpha and the dollar is in follow of A, add A tends to alpha to M of A comma dollar. If no production is found in M of A comma A, then set error to M of A comma A. So what are the components of predictive parser is the stack. It holds a sequence of grammar symbols with a dollar on the bottom of the stack. And the other one is input buffer that contains the input to be with the dollar as an end marker for the parse the string. The third one is a parsing table. And this is a parsing of input that is process. Initially, the stack contains dollar to indicate the bottom of the stack and the start symbol of the grammar on top of dollar. The input string is placed in the input buffer with the dollar at the end to indicate the end of the string. The parsing algorithm refers the grammar symbol on the top of the stack and the input symbol pointed by the pointer and consults the entry in M of A comma A, where A is in top of the stack and A is a symbol read by the pointer. Based on the table entry, if production is found, then tail of the production is pushed onto the stack in the reversal order with the leftmost symbol on the top of the stack. The process repeats until the entire string is processed. When the stack contains dollar and the pointer reads dollar, successful parsing occurs. If no entry is found, it reports error, stating that input string cannot be parsed by the grammar. So there are two types of predictive parser. One is non-recursive and the other one is recursive. First, we will discuss about a non-recursive predictive parser. It uses explicit stack data structure. This prevents implement recursive calls. It can also be termed as table-driven predictive parser. What are the components here is input buffer. It holds the input string to be parsed. Stack. It holds a sequence of grammar symbols. Predictive parser algorithm that contains steps to parse the input string and controls the parser process. Parsing table. It contains entries based on which parsing action has to be carried out. This is a model of a table-driven predictive parser. So this is the algorithm. Initially, the stack contains dollar at the bottom of the stack. Second step, the input string to be parsed is placed in the input buffer with the dollar at the end. If X is at non-terminal at the top of the stack and the input symbol being parsed chooses a production by consulting the entry in the parsing table, replace a non-terminal in stack with a production found in M of X comma A. Compare the top of the stack with the input symbol. If it matches, pop the symbol from the stack and advance the pointer reading the input. If no match is found, repeat from the step 2. Stop parsing when the stack is empty and input buffer reads the end marker dollar. So this is an example constructing the predictive parsing table for the grammar. So production is given and input sentence is given ID plus ID star ID. So first one, we need to eliminate the left recursion. So in this grammar, we have left recursion. So E and E both are same and here T and T both are same. So this is a left recursive grammar. We need to eliminate the left recursion before how to do the algorithm. So this is actually left recursion. After eliminating a left recursion, we got this E tends to T E dash, T dash tends to plus T E dash or epsilon, T tends to F T dash, T dash tends to star F T dash epsilon, F tends to E ID. So no left factoring is not required. There is no common prefixes for any production with the same head. That is no need of left factoring. So we are finding the first of terminal. So in this grammar, what are the terminals we have is plus star, open bracket, close bracket, and ID. These are the 5 terminals. So first of all the terminals are terminal itself. First of plus is plus, first of star is star, first of open bracket is open bracket, first of close bracket is close bracket, first of ID is ID. Next one, we need to find the first of all the non-terminals. So for finding the non-terminal, we need to check the first of E. What is the first of E is capital T. So T is a non-terminal. So again we need to come to first of T. First of T again capital F. So F is a non-terminal. So again we need to come to the first of F. First of F is open bracket. First of F is open bracket. So this is actually first of F. That is first of E. Now what is first of E is, it is a open bracket. Similarly, first of E dash. What is first of E dash is plus and epsilon. So first of E dash is plus and epsilon. Okay. Then first of T. What is first of T? So when we come to first of T, so F is a non-terminal. Again we need to come to the first of F, open bracket and ID. So first of T is open bracket and ID. So what is first of T is open bracket and ID. First of F is again same. First of F is open bracket and ID. So in this way we are finding the first for all the non-terminals. Next one, we need to find the follow. So follow, as per the rule number 1, whatever the start symbol, the follow of start symbol is $. So place the follow of E, that is follow of E is $ symbol. Then next we need to find out what is follow of follow of E, we already find. Next one we need to find the follow of E dash. Okay, so what is follow of E dash? So in this, what is following E dash is nothing is following. If nothing is following means follow of E dash equal to follow of E. Follow of E dash is follow of E. Okay, follow of E dash, which is follow of E. Okay, then what is follow of T? Okay, what is follow of T? So here what is following T is E dash. Okay, follow of T is E dash. So whatever the first of E dash, that will go to follow of T. Okay, so first of E dash is plus and epsilon. So what is follow of T is follow of T. Follow of T is plus and epsilon. Follow of T is plus and epsilon. Okay, next one, here again, next one we need to find the follow of T dash. What is follow of T dash? So T dash, nothing is following, so whatever the follow of T, that will go to follow of T dash. So follow of T dash equal to follow of T. Okay, then what is follow of F? Follow of F is it is following T dash, so whatever the first of T dash, that will go to follow of F. So what is first of T dash is star and epsilon, that will come to follow of F. So what is follow of F is star and epsilon. So in this way we find the follow for all the production. Now we need to construct the table for predictive parser. So when we construct the predictive parsing table, first we need to write for non-terminal capital E. Okay, whatever the first of E, okay, whatever the first of E, in that place we need to replace the production. So what is first of E? First of E is open bracket and ID. First of is open bracket and ID. So open bracket and ID, open bracket and ID. So in open bracket and ID, we are writing the production E tends to TE dash, and here again E tends to TE dash. Similarly, whatever the first of T is again open bracket and ID. So whatever production that starts with the capital T, T tends to FT dash and T tends to FT dash. That we are writing for follow of T. Similarly, follow of F. So in follow of F, in ID production, we are writing F tends to ID. Open bracket place, we are writing F tends to open bracket E. Okay. Then E dash. How to write for E dash? E dash, first we need to write the first of E dash. What is first of E dash? First of E dash is plus and epsilon symbol. Plus and epsilon. If there is an epsilon is there, means in first of E dash, what is first of E dash is plus. In plus symbol, we are writing the production that starts with E dash. That is E dash tends to plus T dash. One more production is there, that is a epsilon symbol. So for that, we need to find out the follow of E dash. In whatever the follow of E dash, in that place we need to write the production E dash tends to epsilon. What is follow of E dash? Follow of E dash is open bracket and dollar symbol. So sorry, close bracket and dollar symbol. So in close bracket and dollar symbol, we are writing the E dash tends to epsilon symbol. Similarly, T dash. So T dash, whatever the first of T dash is star symbol. So here we are writing T dash tends to star FT dash, and wherever the epsilon is there, we need to find the follow of T dash. What is follow of T dash? Plus close bracket and dollar. Plus close bracket and dollar plus close bracket and dollar. So in that place we are writing the T dash tends to epsilon symbol. So this is how we construct the predictive parsing table. So when we construct the predictive parsing table, there are 3 steps. First one, we need to find the first of both terminals as well as non-terminals. Then we need to find the follow of all the non-terminals. After that, as per the predictive parsing algorithm, we need to construct the predictive parsing table.